Okay, so let's talk about sequences. A sequence is a set of numbers with a particular order. There is order to this. It's not just random. And each number in the sequence is called a term. There's two types of sequences. You have a finite sequence. Finite means it's limited. So a finite sequence is a sequence with a limited number of terms. And an infinite sequence is a sequence with an unlimited number of terms. So let's do an example of each type. A finite sequence, it doesn't go on forever. So it might be just 1, 2, 3, 4, and it might just stop there. There's a limited number of terms. Here there's only 4 terms. An infinite sequence, it goes on forever. So it might start at 0 and just go on forever. So the sequence I just gave you was the sequence of whole numbers. These are your whole numbers. So finite has an end, infinite has no end. It never ends. Infinite has no ends. Finite does have an end. Okay, let's talk about notation. The first term in a sequence is denoted as A1. Each subsequent term is denoted as n plus 1, where n plus 1 is the term number in the sequence. So let's do a quick example. A1, that stands for the very first term. So this right here is the first term. The first term is 2. A5 stands for the 5th number in the term. So this is the first one, second, third, fourth. The 5th number in the term is 14. How much is this increasing by each time? 3. So the next one would be 17, then 20, 23. So this is the 6th term, 7th term. This is the 8th term. The 8th term would be 23. Can you guys figure out what the 14th term would be? 41. Okay, so each term value is paired with exactly one term number. So the first term, there's only one first term. There's only one 5th term, okay? The domain is the set of the term numbers. So for example, your domain is always this number. These are the term numbers. That is your domain. That is denoted by n, okay? The range is the set of term values. Okay, your term values are these numbers. That is your range. Okay? In an infinite set, the domain is the set of natural numbers. So your natural numbers are these. 1, 2, 3, and so on. Your counting numbers. So whenever we're doing our sequences, our first term will be 1, not a 0, okay? You always start with 1, your natural numbers. Okay. So explicit formulas, let's give that definition. Okay, so this is our definition of an explicit formula. It's a rule. So guys, all of these are rules. It's telling you what to do with your n value. Here for the n value, it wants you to multiply by 5 and then add a 1. That is the rule, okay? The nth term, your nth term is whatever you want it to be. So for example, they just use n as any number. It represents any number that you want it to be. So for example, if you want the 10th term, just make your n 10. and you plug in a 10. So that means the 10th term, the value is 51, because 5 times 10 plus 1 is 51. So n just stands for how many terms you have. In this case, I chose 10. Okay, and it is a function of n. So we always write it as a of n, a-n, a-n. So that is the meaning of our definition here. So what we're going to do is we're going to give the first 5 terms of each sequence. I'm going to start off with number 8, because that one might be a little bit challenging. So let's look at number 8 together. So remember, guys, from our notes, whenever we're doing a set, we're going to do our natural numbers. So we're going to start with a 1, okay? That is what we're always going to start off with. So I'm going to start off with the first term, that's A1. And wherever I see the letter N, I'm going to replace it with a 1. So right here, I plugged in a 1. Well, guys, what's 1 minus 1? And what is anything to the power of 0? 1. So my first value is a 1. The first number in the sequence is a 1. Now let's do the next natural number, which is 2. So I'm going to erase this and put 2's there. We're going to plug in a 2. Well, 2 minus 1 is 1. What is anything to the power of 1? Itself. So that'll be 3 halves. Next, we're going to do the third term. So I'm going to plug in a 3 for the n. 3 minus 1 is 2. So I'm going to do 3 squared, which is 9. 2 squared, which is 4. Okay? You guys do the fourth and fifth term. Let's move on to number 12. Now, number 12 has this little exclamation mark. And an exclamation mark means factorial. Okay, so let's write over here in our notes column. Whenever you see an exclamation mark, that means factorial. And what that means is if I have 5 factorial, this means 5 times 4 times 3 times 2 times 1. If I have 4 factorial, that means 4 times 3 times 2 times 1, which is 24. 3 factorial is 3 times 2 times 1, which is just 6. 2 factorial is 2 times 1, which is 2. What do you think 1 factorial is? 1, okay? So that means for this sequence down here, you're going to start with a of 1, and it's going to do 1 factorial minus 4, which is just 1 minus 4, which is negative 3. So we know our first term is negative 3. Next, you're going to plug in a 2. So you're going to plug in 2's here, and let's see what we're going to get. 2 factorial is just 2, and 2 minus 4 is negative 2. So I know the next number is negative 2. Let's try the third one. Third one, 3 factorial is 3 times 2, which is 6. Minus 4 is 2. So I'll let you guys do the next 2. I'll let you do all of these examples, and then we can come check them later. I'll let you guys try.